All right, so we can get started. Start out with, we'll do an overview of our agenda for today. Today we will be reviewing what is Wi-Fi monitoring from the client perspective, reviewing some monitoring goals that you might have in place. We will have general and industry-specific use cases, some recommended deployment locations, going deeper dive into the Wi-Fi sensors, and then we'll end off with a product tour with Stefano and NetBeast solution. So what is Wi-Fi monitoring from the client perspective? In short, it's just gathering message or metrics of your wireless network via dedicated sensors. Do this by setting those sensors up to one or more of your SSIDs as if it's just another client. Now, this type of monitoring is gaining a lot of traction because it's 2018. Even your dishwasher is connected to the Wi-Fi. And in addition, there's a lot of moving parts with your wireless network that may make it difficult to figure out what you need to troubleshoot if an issue does occur. Now, in the typical first steps of trying to figure out when a wireless issue is logged, somebody may go to the wireless controller or AP dashboard to see what type of metrics those are giving you. Now, with that, I'm not sure if you've ever ordered anything online before, but sometimes what you order isn't necessarily what you receive. So it only gives you half of the picture. What you need is a sensor on the other end to give you the whole view to help you find that smoking gun of what may actually be causing that network trouble. So now that you're interested in monitoring from the client perspective, where do you start? Well, you need to institute some goals. Here are some goals that we've seen some of our customers in the past have when trying to monitor their Wi-Fi. First, test Wi-Fi authentication and association. Essentially, just verify that the Wi-Fi clients can connect to the SSIDs, authenticate, and associate with the network. Next, test internet service availability and performance. Essentially, you want to get what you paid for. You want to make sure that you're able to connect to the internet and you have the download and upload speeds that are in line with your SLAs. And lastly, you want to test Wi-Fi signal coverage and performance. You can do this by collecting real-time Wi-Fi performance metrics such as signal strength and link quality, as well as perform proactive performance measurements via ping, iPerf, and other tests. So here are some just general use cases that can benefit from the Wi-Fi monitoring from client perspective. First, we have quick detection and troubleshooting of Wi-Fi issues, performance measurement in high-density areas, SSID and service availability after configuration changes. Now, this one's kind of a big one because typically when you do configuration changes, those are in off hours, and then the first contact would be the end users in the morning. Whereas if you have a sensor in place, you'd be able to make sure able to validate those configuration changes in real time and not have to experience any end user issues. And lastly, tuning transmit power adjustment algorithms post-site survey. Now, we do have some industry-specific use cases that I'll be going over today, but if you're interested in more, please feel free to visit the resource section on our website where you can download one of these use case papers. One of the most common use cases we've seen has been in the higher education space. It's been a while since I've had to take a test, but test taking has evolved from the old-fashioned pen and paper to using web applications such as ExamSoft. Now, with these applications come strict parameters so that if a student does experience some sort of network issue, it could become a headache for the student, for the professor, and yourself. Now, to combat this, if you place a sensor in these classrooms to run proactive Wi-Fi tests to ExamSoft, you'll be able to go back to the time of the complaint, see how your client was connecting to ExamSoft, and see if it was actually a network issue or not. Another use case that we do see has been in the tech space. Open space offices have become very popular lately, with users connecting with multiple clients, such as their laptops, tablets, and phones, and as well as moving and working remotely throughout the office, going into the deep corners to get some silence from the chatty Cathys that they may have next door. And when they go into those corners, they may have experience some issues, and they will be sure to let you know about it. Well, here, if you go through via the AP, you may see what they should be receiving, but not necessarily what they are receiving. So you can deploy a client into the nooks and crannies and make sure that you have the whole office environment covered. Now, to capitalize on that, here are some recommendations of where you might want to deploy Wi-Fi sensors. So in the corporate environment, we have C-level executive offices, which if they log the complaint, typically goes to the top of the list. So you want to know what's going on there. We have boardroom, conference rooms, lobbies, and the open space offices I discussed before. In education, we have classrooms, labs, libraries, as well as there's also dormitories. Students love to stream their Netflix, and they will be sure to let you know if they're experiencing any issues about it. Hospitals, we see them deployed in ERs, ICUs, and seeing a heavy use case in the cart on wheels because of the mobility of these carts, having to switch from access point to access point. You want to make sure that that connection is there. And lastly, in the retail space, this has seen a transition as well, going from the old-fashioned type cash registers. Nowadays, it's typically some type of tablet or PC, as well as then the guest Wi-Fi and the PCI Wi-Fi. Now let's dig a little bit more into the actual Wi-Fi sensor. It's currently conformed with just a small computer equipped with a Wi-Fi card. Typically, you have a choice of going with an in-house solution or a commercial solution. With the in-house solution, it might be a little bit easier to configure the sensors yourselves. However, it might be difficult to be able to build and maintain a system that will receive all the data collected. Now, on the flip side, with the commercial solutions, it might be a little bit more expensive. However, you won't have to deal with the hassle of building and maintaining any systems. At NetBees, we take a hybrid approach. So we take an off-the-shelf type sensor, and we configure them before they arrive at your doorstep, so it's all plug and play. In this slide, you can see a little bit behind the scenes of our sensors. It's Raspberry Pi 3B, which is one of the more popular single board computers, as well as an ASUS 56 AC Wi-Fi card that's compatible with 802.11ac. And then in the picture there, you can also see it comes with some Ethernet ports that will give you a permanent and stable connection from your sensor to the dashboard. So even if the Wi-Fi does drop, you still be able to connect to the sensor and be able to perform some type of commands or scripts to be able to figure out what the issue may be. Now, whether or not you're looking to build your own or go with a commercial use, we've done a lot of research into the Wi-Fi sensors, and here's some of the stuff that we have found. With the 3B model of the Raspberry Pi, these ones are only able to connect to a 2.4 gigahertz, up to 50 megabits per second. With the 3B Plus, these can connect to the 2.4 and 5.0 gigahertz, but because of the 1x1 radio, it can only get up to 75 megabits per second. And while having the dual band is nice, what engineers do need to measure the download and upload speeds to see the average for the Wi-Fi user. So this could cause some issues. But later next month, they will be adding on a PoE add-on so that you are able to have the power over Ethernet connection, help to power your sensors. Now, because of some of the issues with the 3B plus. Like I mentioned before, NetBees, we decided to add on the ASUS AC56, which will give you 150 megabits per second on the 2.4 gigahertz, and then 250 megabits per second on the 5.0 gigahertz. Now, internally, the agents do run on a Linux operating system. More specifically, the Raspberry Pi comes with Raspbian Linux distribution, which is a derivative of the Debian. In these environments, there are a bunch of commands that you're able to use to help configure the sensor to your Wi-Fi network. But here's a list of the top 3 that we think that you should be aware of. There's IW, which is command line utility to manage the 802.11 devices. The IW config, it's a deprecated command replaced by the IW, but sometimes is still in use. And then the WPA supplicant, this supplicant helps support WEP WPA and WPA2 authentication. Now that brings us to the end of the first part of the webinar. In the next section, Stefano will go through a demo of the NetBees dashboard, highlight how the agents are managed, what type of Wi-Fi metrics we're able to display, and how we can help monitor your Wi-Fi. And he'll review some of the new features that were introduced in the recent release of 1.4 of NetBees that was in July.
So as you can see here, you can see our dashboard. We're really excited to show you the latest improvements that we introduced in the version 1.4, as I was saying, released on July 2018. But before maybe going into the details and the specifics of the Wi-Fi monitor with NetBees, just for the users that are not familiar with our system, NetBees comes with a dashboard that runs on a dedicated server, can run on the cloud or on-prem, and then you have a bunch of sensors that you can connect to your network. We have fast Ethernet, Wi-Fi, virtual cloud sensors, and so on. So really the 2 main elements of the dashboard that you should be aware is agent and targets primarily. Agents are, again, the sensors, which can be hardware or software, while the targets are the applications that you monitor with the sensors. So as you see here in the bus tab, as we call the main view of the dashboard, is the status of all these all the agents and targets monitored. Plus, we also provide a network rating, 1 to 5 stars, based on the number of incidents that the agents detect at a specific network location, and that would be an agent incident, or with the specific application, and that would be a target incident. And as you see, there is also a third indicator, which is a donut chart about Wi-Fi incidents. And I'll talk more about the Wi-Fi incidents later, as I first want to introduce the Wi-Fi sensor and how it's managed on the dashboard. So I'll move to the Agents tab. Here, as you can see, we have a certain amount of sensors managed by the dashboard, from Wi-Fi to fast Ethernet and so on. And you see that if I apply a filter to the wireless agents, you can see that some are connected while some are not connected to the network. And that can be shown because the one connected have this light blue symbol of the Wi-Fi, and the one not connected to an SSID have this red symbol. If you click and see more in detail, for example, this a sensor in San Jose, you can see that the sensor has 2 interfaces, an Ethernet and an W10. The Ethernet is solely and primarily used to establish the control channel back to the server. Because if you're looking to monitor a Wi-Fi network that is unstable, you don't want to see the agent continuously dropping off your dashboard. So the Ethernet connection allows a stable and permanent connection to your server, while the WLAN 0, as in this case, is used to exactly monitor and test your Wi-Fi network. Here you can view a bunch of ping DNS, HTTP, and traceroute tests running real time by this sensor. And in the next tab, we have the actual SSID metrics that are collected by the Wi-Fi card that this sensor is equipped. So a little like more information about this view. We present the amount transmitted and received bits per second. As you see, these sudden spikes most probably are related to scheduled tests, as we call them. So we run tests like iPerf or speed test as well. So you can measure the throughput, download, and upload speed of your network. We have the link quality, which factors also the noise and the signal strength. And this is a metric that is provided by the ASUS driver and chipset. We have the signal strength in dBms. This is the strength of the signal as connected to the access point. And then the bitrate as established with the access point, plus channel and the BSSID. So this is the really client perspective information that Jordan was speaking about earlier in the first part of the webinar. And down here, we have also all the information that you need to know about the current connection of that sensor to the current BSSID. I'm sure, like, if you're familiar with the wireless network, this is nothing new. Another interesting thing is that, of course, you can rely on historical data, so you can see if this value change throughout the day or week. And another very useful function is to do an SSID scan for the networks that are in range and detected by the sensor. Then you can, of course, sort this result based on channel, frequency, or signal strength. So this is something very useful to do your assessment remotely for all your locations. Another very important function with each sensor is like having straight SSH access to the sensor. You have access to the console in the agent. You're here on a Linux environment, so think about you can really do a whole bunch of commands that you would like to do on a regular basis. Really, this is like the goal is like complement or show some. Basically, you can run your own commands without necessarily having to integrate the specific command with the NetBeans dashboard. Okay, so now that we'll review the agent detail view, as we call it, for this of the NetBeans dashboard, we introduced in 1.4 a new tab called the Wi-Fi tab. And the Wi-Fi tab, the goal is to aggregate metrics from multiple sensors that are monitoring a specific SSID. In this case, is NetBeans. So this tab is very useful to understand and to locate any problematic areas where maybe the link quality, the signal strength is low, or the performance is really low. You can see here that I have a certain number of sensors that are connected to this SSID, both in Pittsburgh and in San Jose. And you can see the overlap information wireless metrics, as I showed you before, on an individual agent. These lollipops, the green and the red one, shows when a specific agent disconnects or reconnects to the network. So it's really useful to see how many connection and disconnection event. This specific agent is periodically connected to an SSID and then connecting to another one. And then down here you have alerts, the aggregate number of alerts for this specific associated with this SSID. And this alert will generate then eventually a Wi-Fi incident that, if you recall, I show you in the bathtub right here. Right now, we have no Wi-Fi incidents with the only SSID that is being monitored by our sensors. And this is good because it means the network is running overall good and no agent is having performance issues. However, if a certain percentage of tests run by these 5 agents trigger alerts, and the threshold is user defined by default is 80 or 90% of tests, then you will create the dashboard, the system, and this will trigger a Wi-Fi incident, meaning that something is happening on that specific SSID and the wireless engineer should take a look. So this is a really useful function to be proactive without expecting your user to find problems for you. The Wi-Fi incident threshold, as we call it, is configurable under the anomaly detection section of NetBeans. Here is where you can set the threshold that will cause a trigger of a Wi-Fi incident. Okay, so let's see how easy it is to monitor a Wi-Fi network. It's very simple. As you can see, let's imagine I just created a new SSID and I want to monitor with a certain number of sensors. So the Wi-Fi tab is the best place where I can do this. I click on Add Wi-Fi Network. I add the name of the SSID. In this case, is the NetBeans guests. I can add a description also to my SSID. I can put a pre-share key password. And then, of course, here is the pre-share key. Of course, we support also EAP methods with radios, 802.1x, PIAP, EAP TLS, TTLS, and LIB. So really, enterprise authentication is as well supported. I click on Save and Continue. And now that I have created my SSID, as you can see here, a new profile appears on my dashboard. Then I can select maybe the webinar agent that they were not monitoring any SSID. And now, basically, I'm done. I created my SSID to be monitored. And now the dashboard is pushing the profile to the 3 agents that I've selected, and then I will start collecting information from the agents. Of course, now the agents will try to establish connectivity with the access point in range, if in range, and then they will start showing data here in the dashboard. So as you can see, the workflow was pretty simple, and this was a major improvement in the last release, 1.4, as I said. Because before 1.4, the NetBeans user had to repeat this process on an individual agent, but now the workflow is so much simplified. And as you can see here, I started having the first agent connecting. This is the agent number 3, and then I'll start getting also agent number 2. Of course, then the end result will be like this NetBeans SSID that I was showing you before. Okay, it looks like we are done with the product tour of the dashboard. Of course, if you're interested in learning more about the dashboard and the sensors, please feel free to request a demo at our website, netbeans.net, and Jordan and the rest of the team will be happy to schedule a time for you. At this point, we can go to the Q&A section of the webinar. And let me see the first question. Okay, very well. So we have the first question that it was asked. Okay, so the question was, are any other dongles supported other than the Asus? So yes, different dongles are supported as long as Linux sees them. Then there are some tricks, of course, that not all the dongles report the data in the same way. So if you want to have a list of dongles supported, you can contact us or also search on our NetBeans blog. But I actually have an update from one of our developers who says that mainly the driver must be 8812AU. So if you have a Wi-Fi NIC that uses that driver, then it will behave very similarly at least from an integration perspective, with Linux and with our agent. As a reminder, we generally include the hardware as part of the subscription, so you don't have to go through this manual configuration, right? So we just, send you the server software or cloud dashboard sensor, and you're ready to go. So you don't really have to hack it too much. Another question is, can I add a certificate to each device to connect to WPA2 network? And yes, you can do that. Generally, what we're doing is like we support SSID with same name but different profiles, right? And then you can have individual or a certificate on a per agent basis. Of course, it might be not very efficient from a configuration and maintenance perspective, but that's definitely possible. Okay, another question was, how long does a Wi-Fi deployment take from start to finish? And that really depends on the type of deployment that you're looking at. I can tell you that if it's whether it's cloud or on-prem, on the cloud, of course, provisioning the dashboard and the server is immediate, and we do it. If it's on-prem, we'll send you a virtual appliance, and you just import it on your VMware or hypervisor, and you're good to go. So fairly quickly. Then the next phase would be the deployment of the sensor. And as Jerome was saying, is that you have to consider your monitoring goals. If you're simply like testing connectivity and internet access and speed, generally one sensor per location is enough. So it's, it is based on sending those sensors out in the network and plugging them straight into the network. While if you're looking to also monitor signal coverage and so on, then that of course will require more time, more sensors, and more planning also on the wireless engineer's end. So it really depends based on the specific project. But it's fairly simple. At least we try to make the process and deployment very easy and plug and play. Okay, so how do you auto flip bands for testing? I guess this is another question. I suspect this is something like SSID hopping eventually. So that's a feature that we're working on relatively to SSID hopping, but right now we also are able to do this on the agent side. That means the configuration is done through the console and is not integrated with the dashboard. So you can do it either manually by writing a script. Actually, I have an update to the question, same SSID, but with both 2.4 and 5 gigahertz. So yeah, that's either, of course, the access point can push from 2.4 to 5 gigahertz and vice versa as a client. So that's transparent for the client itself. While if you want to actually the sensor itself hop between 2.4 and 5, then you would have to configure SSID hopping. And then you can pick and choose the interval, the hopping interval. You can search on our blog. We actually wrote a blog post about that, or feel free to contact us. Okay, with that was the last question. I think we had a couple more, but we can answer offline. If there is anything else, feel free to send us an email anytime, or even go to our website. You see a small chat window on the bottom right on our website, netbiz.net, and we can continue the conversation there. Thank you so much for attending this webinar, and have a great day.